And just to take a look at a few more examples that might be really tricky. Exponent rules. Again, same stuff. We've got interesting powers here. They're not just numbers. We do have variables, but we'll just apply our rules. So reminding ourselves that if you see a little dot there, that just means a times sign. And in this first problem, I see a fraction, so I know I'm going to be subtracting the top from the bottom in terms of the powers. But I also notice that I have brackets here. So let's go with what's inside the brackets first. Let's try and simplify that. That's x to the power of 2n times x to the power of 5. And that is going to give us, because I'm timesing adding the powers, x to the power of 2n plus 5. And now all of that is under the bracket times p. And on the bottom I've got x to the 4p. So we need to remind ourselves that when we've got a power outside a bracket, we need to times it to the powers inside, or to the exponents inside. So the exponent outside gets times onto all the powers inside. So here, I'm going to have x to the power of 2n plus 5, and I need to expand that p and times it through to everything in there. And it's still over x to the 4p. So we're going to get x to the 2np plus 5p all over x to the 4p. And as my last step here, so sorry, that was one step. As my last step here, doing subtraction, I know that I am going to have x to the 2n plus 2np plus 5p, that's the top power, minus the bottom power, which is 4p. And simplifying that, I see I've got like terms here. I'm going to get 2np plus p. And again, I could factor that if I felt like making it prettier. Pull the p out of those two terms, 2n plus 1. Okay. Next example. Again, I see fractions, so I know I'm going to be subtracting the powers here. I see brackets. Here on the top, the brackets are just being used to kind of be another way to describe the fact that I'm timesing. Remember, if you don't see anything between a bracket and another bracket, or a bracket and a number, it's just an invisible time sign. So on the top, m to the power of p minus 1 times m to the power of 1 plus p. Adding those, we've got m to the power of p minus 1 plus 1 plus p. And that simplifies to m to the power of p plus p is 2p, and minus 1 plus 1 is 0, so we don't have anything else. And let's go ahead and simplify that bottom while we're at it. Here I see I've got an exponent 4, or an indice of 4 on the outside, and I know I need to times that to the power inside. Because there's more than one term, I will put brackets. So that is going to be m to the power of 4 times 2 plus p. And expanding that bracket out, making sure everything gets times there, we've got m to the power of 8 plus 4p. And now I've got some subtraction. Top minus bottom. M to the power of 2p minus, in brackets, 8 plus 4p. Again, in brackets because there's more than one term in the bottom there, and I need to be sure to subtract both of them. Now I need to expand those brackets through. So that becomes m to the power of 2p minus 8 minus 4p. And as I simplify this, this becomes m to the power of negative 8, adding my like terms here, minus 2p. So that's alright, but because those are negative powers, I might think about trying to simplify that a little bit. Again, I can factor out a 2 here, so I might take out a negative 2 for plus p. And because it is a negative, you haven't learned about negative powers yet, don't worry about it. You can leave this as your answer. But because it is a negative, I know that I can also write that as 1 over m to the power of 2 bracket 4 plus p bracket with a positive instead. So a lot of tricky steps in there, but as you get familiar with those, you'll recognize it. And again, this last one is just because it's a negative power. So if you don't know about the negative indices yet, or the negative powers, that's alright. You can leave it as the first step there. But if you're aware of them, pay attention to that and try and build to the second final answer down there. Effectively, they mean the exact same thing between those two. It's just one way to write it without the negative. Not sure that either of them are actually prettier than the other.